Hi everyone, thank you for joining. So in this video we're going to solve another integer equation. So x and y are integers, and this is a question from Romanian mathematical Olympiad. So we want to know the values of x and y, right? If you'd like to pause the video and try it yourself first, then we could go over it together. Right, so we can start off by multiplying everything by 4. So we will have 4 x to the 6 plus 12x cubed plus 4 is equal to 4y to the 4, right? And then why did we do that? Well, we could see now that if we write 2x cubed plus 3 squared, we will get the first two terms, and then we'll get plus 9. So if you subtract 5 from it, left hand side is the same, so that is 4y to the 4. Right? So in other words, we have 2x cubed plus 3 squared minus 4y to the 4 is equal to 5. And now we have, we can use difference of squares. In fact, we can write 2x cubed plus 3 squared minus 2y squared is equal to 5. So notice this is a squared minus b squared, which is equal to a minus b times a plus b. Right? So that means we can now write this as 2x cubed plus 3 minus b, so that's 2y squared, multiplied by 2x cubed plus 3 plus 2y squared. That's equal to 5, right? Now we have a prime number 5, so the only way we could get, well, all the possibilities are 1 times 5, 5 times 1, minus 1 times minus 5, minus 5 times minus 1. Yeah. Of course, two of these possibilities are not going to work, but we're going to do it explicitly anyway, because if you think about it, this always has to be bigger than that, right? Because x and y are integers. We have this left-hand side bracket comparing with the right-hand side. The claim is right-hand side bracket will always be bigger than that. In other words, we can, based on this, we can say this cannot have any solutions. We will see it explicitly, or this can't have any solutions because the right-hand side bracket is as smaller, which it shouldn't be smaller. Yeah. Okay, but let's zoom out a little bit and then test these solutions, right? Possible solutions. So let's start with 1 and 5. So we have 2x cubed plus 3 minus 2y squared is equal to 1, and 2x cubed plus 3 plus 2y squared is equal to 5, right? Using that. Okay, so if we subtract, let's subtract the first from the second, so that we have 4y squared positive is equal to 4. So y is equal to plus or minus 1, right? And if y is equal to plus or minus 1, let's sub into any of the equations. So let's sub in there. We have 2x cubed plus 3 minus 2. Well, whether you sub in plus 1 or minus 1, it doesn't make any difference because y is squared. Right, so let's leave it as 2, that's equal to 1. So we have 2x cubed is equal to, well, if you take minus 2 on the other side, you get plus 3. And then if you take plus 3, you get 0, right? So x cubed is 0. Implying x is 0, so 0, 1, 0, minus 1. These are two possible solutions, right? Now let's try the second set. So we have 2x cubed plus 3 minus 2y squared is equal to 5. 2x cubed plus 3 plus 2y squared is equal to 1. Let's use the same trick, the second equation minus the first equation, we get 4y squared, but then we have 1 minus 5, which is minus 4, and that's not possible. Because you can't have 4y squared. You can't have y squared to be minus 1 if y is a real number, right? Now, I will leave the third one to you to prove it that there will be no solutions there. And the last one which we could have guessed the last one as well, but let's do it explicitly. We have 2x cubed plus 3 minus 2y squared is equal to minus 5. 2x cubed plus 3 plus 2y squared is equal to minus 1. So if you subtract first from the second, we have 4y squared is equal to minus 1 minus minus 5 is plus 4. So y is equal to plus minus 1. Okay. All right. So if you take these values back in and one of the equations, so what we get is we get 2x cubed plus 3 minus 2y squared. Well, instead of y squared, let's write 1. Plus or minus 1 doesn't matter, we're squaring it, so it will just be 1. And that's equal to minus 5. So we have 2x cubed plus 1 is equal to minus 5. 2x cubed is equal to minus 6. X cubed is equal to minus 3, which is not an integer solution, right? Okay. So the only solutions we have is then these two here. Okay, now this is of course how one approaches the integer equations, but can I just point out before we end this video, whenever you are facing an equation, whether it's an integer equation or not, it's always good to have an educated guess. Yeah. So in other words, clearly, if you set x to be 0, you can immediately see that we have 1 plus y to, 1 is equal to y to the 4. So y has to be either 1 or minus 1, right? So that's already there, the solution. And the other thing is that when you set y to be 0, you have x to the 6 plus 3x cubed plus 1 is equal to 0. And then what we could do is we could say, for example, we write this as a quadratic, k squared plus 3k plus 1 is 0, where we let k to be x cubed, right? And if you look at the discriminant of this, so b squared minus 4ac, right? You get radical. And if you get a radical, that means you're not going to get a integer value for x, right? So this is more sort of, this here is more intuitive way of thinking about it, yeah? Rather than being very mechanical. And what I'd like to point out for those, if these steps aren't clear to you, for example, if you are wondering why did we multiply everything by 4 here, why didn't we multiply by 2, for example, or any other number, with the integer equations, comparison is quite important. So what we're trying to get here is that this point there, where you have difference of squares. Because once you have difference of squares, you can factorize it, and if it is equal to a prime number, you compare it. And this is a very strong method in solving integer equations. Well, I hope you found this helpful. I hope you found it interesting. Thank you so much for joining, and I look forward to seeing you in my future videos. Thank you.